Hello, Year 11s. Ipshita, hi. I've no idea if I'm saying that right. I hope I am. I know you just kind of tend to go via ips. I'm just fiddling around with my computer to have the chat up on one of the screens. And then the other one. There you go. No, it's absolutely fine. I've got it all sorted. Right. Can you hear me? Can you hear me okay? Give me a thumbs up if you can. Can I just call you Ips? That's where we need to realize the time lag with you being in the UK. That'll be interesting for me to know. Cool, thumbs up. I like it. Okay, so what I've done is I've taken your questions. I'm just gonna crack straight on with this. So I'm gonna share my screen with you. Share screen. There we go. And go hide. Cool. So you should now be able to see my screen. So what I've done is I've put your 4 questions up on my document. I'm going to go through each one of them. And what I've done is not only will I do some theory behind each one, but then we'll look at some questions regarding each one that you wanted. Okay. So the first one that I'm just going to do a title. Got to do a title here. So we've got Year 11 revision. I wonder if anyone else will turn up. Sometimes my kids just randomly turn up from my classes because they're on my subscribe list. So every now and again, someone gets a notification. Year 11 revision. Okay, so I think we can pretty much use your questions as learning objectives. We can say, be able to write, ionic half equations. So that's your able to. By the way, I tend to do 3 different types of learning objectives. I tend to do a knowledge-based, which is your easy. This is know, knowledge. I tend to do a U for understanding, and then an A for able to. And able to usually reflects, I've just done something wrong. I'm writing aldehyde there. Able to. Oh, what's wrong with me? Nah, able. Usually that will relate directly to exam questions. That tends to be how it goes. So that first one, this one will be a learning objective of be able to understand and build half equations. Now you've done ionic half equations, and there's a tiny amount of I feel like there's detail here that's missing, because in GCSE you only really come across electrolysis ionic half equations, but every now and again it does crop up that question. And I'm gonna before I jump in onto a topic, let's then do these 2 now go together, and these 2 are big. You've pretty much just said, teach me the whole of this topic. That whole thing is energetics, and it's energetics. And it was really interesting when I saw your question. I was very much aware that you were giving me all these pieces, and I was like, she doesn't know the topic title as being energetics. And so what I'll do is I'll do a little bit of revision on energetics, then point you in a direction of one of my other webinars that I've done in the past. But I'll go through that today, and we'll look at some exam style questions. And molar enthalpy change. Now the problem is there's lots of details here, because that's a huge question mark for me. It's kind of like, are you not understanding what delta H is? And this is where the feedback on the chat will be super useful. So can you give me a bit more detail as to kind of what you mean by molar enthalpy change? Like, are you just saying that you generally don't understand this as a topic and you'd like me to do it in general? And I'm happy to do that. It won't take me especially long either, but just let me know. The next one is draw the repeating units. That's another able to, which is quite nice. Draw repeating units of polymers. It's interesting how you chose to calculate delta H. Do you mean bond enthalpy? No, you've put bond enthalpy calculations in here. There's your bond energy calcs. Well, are you talking about calorimetry there? Because there's 2 types of calculations involved in energetics. What I'll do, Ips, is I'll do both. I'll just go through both with you, and we can see if we can muddle our way through, and then perhaps you can go back and look at some other questions, and then you can get back to me and we can have another one of these. Okay, so let's do the ionic half equations first. So, okay, so the first thing here is let's do a little subtitle. And this is where I haven't really left myself enough space. Let's move that down. There we go. So let's do half equations as our subtitle. No. Okay. Yes, please. The calculations for energetics and the graphs and energy profiles. So that's the whole of energetics. That's absolutely fine. Yeah, that's absolutely fine. I'll do that. That's cool. I'm just suddenly thinking that my laptop might die, so I'm just going to get the power pack for my laptop. Just plug that in, just so it's there, just in case. We'll see how we get on with the battery. It's on 77. Okay, so let's do half equations. Now, you said ionic, which is really, really tricky there because there's kind of two places where half equations make an appearance. And at GCSE, the first and probably the most challenging, and this is kind of where your question hinted, you said, where do the electrons go? What that means is the half equations that you're talking about are electrolysis. Yeah, electrolysis. Now, just to say, by the way, that there is no actual dash there, but I do that because electrolysis, the name itself actually tells you what's going on. The word lysis means to split, and electro, of course, meaning electricity. So, I mean, this is splitting, and this actually leads us to our definition. This is splitting, and just to put the definition here, to split ionic compounds. Ionic compounds, I'll put this in a box. Ionic compounds using electricity. Now, that's the only place where you're going to see electrons at GCSE. So I'm just going to put that in a bubble. Okay, so the other place that you tend to see half equations is sometimes in chemical tests. That's things like, but they're not quite the same. These are ionic half equations where you get to, it's things like in chemical tests, it's things like silver nitrate being the test for that. Lysis means to break down. Yes, that's correct. The biologists stole it from me. Ips. They literally nicked it. That's why you get the other versions, since you mentioned that. You then get hydrolysis, yeah, to split using water. Yeah, that's another great one. And then you also get thermolysis. Now, thermolysis is an interesting one. That's splitting using heat. We don't tend to call it thermolysis in chemistry. We have a different name for that. We have thermal decomposition. Decomposition. So we have thermal decomposition instead. I don't know why. I think it just sounds better. I have no idea why though. But hydrolysis, yeah. There's lots of other lysises. There's also photolysis, that's splitting using light. It's all good question, all good lysis-based words in chemistry. So in chemical tests, you come across half equations, but there's no electrons. Yeah, that's something we can talk about later if you want me to. Just let me know if you'd like me to. Otherwise, I'll focus on the electrolysis bit. Okay, so are you okay with me just quickly running through a tiny bit of electrolysis understanding before I start doing half equations? Because without really the understanding of what's going on there, it does make the half equations a little bit tricky. So in terms of, I'll keep it short. I'll do the revision bit. Yeah, electrolysis. The only thing that I really want to do here, I'm just going to increase this pace. So in electrolysis, the key thing here is understanding what's happening practically. Because if you have a scenario, yeah, you've got water here. If you've got a scenario, now there's two types of electrolysis, and you need to know this. There is electrolysis of molten. Now the word molten salt. Now that the word molten means liquid. That would be something like NaCl. Yeah, that would be a molten. The word molten actually means hot liquid. So you wouldn't call water molten. because it's a liquid when it's cold, but you'd call lava molten. Yeah. Are my messages having a slight delay? Yes, they are. But it's okay. I can kind of we can work with this. It's all right. So we've got molten electrolysis of molten salts, and we've then also got electrolysis of aqueous salts. So this is aqueous salt solutions. Aqueous salts. So that's something like sodium chloride aqueous. Now these are very different in the way that they behave, because if you have so the two pictures, what does molten salt look like? We know that sodium chloride is made up of Na plus ions and Cl minus ions. If I had molten salt, that's what it would look like. The ions are free to move. They can move around. Yeah, it's very hot. But the key thing here is these are the only ions here. Yeah, only ions are Na plus and Cl minus. And because they're molten, this is the key bit, because they're molten, they are free to move. Free to move to carry charge. That's what I tend to always say that. And by the way, that's the explanation for why moltens conduct electricity, if you're wondering. It's really a bad habit of mine, how I have like a sentence in my head and out pops an answer that goes kind of with it. So, but that's what it looks like when it's molten salt. There's no other ions. The next thing is, what happens if I'm in aqueous? If I'm in aqueous, if I've been dissolved in water, I have a slightly different picture. I have the picture of Na plus, Cl minus, Cl, I'm just going to put a few more on there, just the same number. But now we also now have in this box, we have water, and here's the really important kicker, H plus and OH minus. Now, if you're wondering it, like all students do, where have the H plus and OH minus come from? What they have come from H2O splitting apart to form a H plus and OH minus. So this is something that's happening all the time in water. So every now and again, by the way, it's about 1 in a million. It's actually about 1 in 10 million, 10 to the 7. So for every 10 million waters, one has fallen apart. And what that means is it just provides me with these two ions as well. And that's really important. Now, what I'm going to do is I'm going to focus on the molten because they're the easiest. And then we're going to drop to aqueous. So at this point now, what do we now do in electrolysis? What we now do is we now introduce some electrodes. Yeah, so there's our electrodes. Let's hook it up to a battery. Now, we know that the long one is positive and the short one is negative. I'm just going to do that as well, just to make it really clear. Right, so what we can now do is try and understand what's now going to happen. So, first question I've got is, do you know what these electrodes are called? The positive electrode, we know that the negative ions are called anions. Just to let you know the reason for that, a negative ion. It's literally where it came from. And then we have cat ions. Sorry about that. They used to be called apions. They used to be. They're no longer called apions because people were getting confused because they were too similar. So they changed them to cat ions. So we've got A negative ions and cat ions. So now let's figure out where these are going to go. So the cations and the anions are going to go to different electrodes. The cations are going to go over to here, to the negative electrode. So this now gets called the cathode. It's called the cathode because it attracts cations. And then the anion goes over to here, and this is called the anode because it attracts ions. Now, students often forget that. So there's a nice easy rhyme, which you've probably already been taught by your teacher. Cathode, anode, anions, cations, absolutely right. So if you're ever thinking about the electrodes, yeah, the electrodes, you have panic. You have panic. And what panic says is positive anode, negative cathode. It's just nice to remember that. Nice and easy. I love panic. It was one of my favorite things that I picked up. Really handy. So, okay, so now what's happening at this point? So if we now need to look at the half equations. So the sodium cation is going to wander over to the negative electron and it's gonna hit it. And what it's going to do is it is going to gain an electron. Now you're going to say, how did I know which side the electron went on? Well, there's two clever, first time I've heard of panic. Oh, panic's so handy. Panic over the electrodes. It's super handy. Positive anode, negative cathode. Just remember the I doesn't really do anything. But you can call it pank if you like, but panic's just one that works for me. You're going to ask me, how did I know the electron went on this side? So number one is we know that there's an arrow in a chemical equation, and that arrow divides up. These are our reactants. Reactants go in. Everybody gets that in years 7, 8, 9. And these are our products. And products come out. So would you agree, if somebody is going in, you can gain electrons? Notice the word gain has in it. Yeah? What that tells you is if you're gaining electrons, the electrons are on the left. Now by the way, I love all of these tricks that I can teach you in terms of words, but in reality, there's a far better understanding in this, which is this is positive and this is negative. They're going to attract each other. What that means is they're going to go on the same side. They're literally going to come together. Two arrows. So it's just nice for me to be able to get one of the most important things in the history of chemistry, Ips, is that opposite charges attract. And this tells you where the electrons are going to go. So if you've got somebody positive on the left, the electrons are going on the more positive side. That's it. So the next thing, of course, is products out. That's loss. Yeah, would everyone agree with that's loss? Well, it has the O in it for out. That's just one of the ways that I often mention, yeah, of how knowing what in and out and gain and loss and how it translates to that. And you'll probably then have come across oil rig. Oh, so important for electrolysis. Oxidation. Oh, I've got to do it properly. Oxidation is the loss of electrons. And then reduction is the gain of electrons. Gain of electrons. So important, so important. Gotta love oil rig. It's one of the most important things for electrolysis. It makes everything so much easier. I spend my whole time living in that. You said to me that you're going to be doing A-level chemistry. That there is incomplete for A-level. We love, yep, heard of oil rig. There's actually, so oil rig is an amazingly useful tool. But I invented a picture of this that helps with A-level, because metal oxidation, we'll usually talk, in electrolysis and oxidation and reduction reactions, we're usually talking about metals. So in terms of oil rig, oxidation, the metals lose electrons. The oxidizing agent, so this is the oxy agent, is therefore gaining it. Yeah, that's loss, and therefore that's gaining. It's a really handy picture. Metals in reduction. Metals reduction is the gain. So in terms of red reduction, the metals are gaining electrons. That's a gain. And therefore the reducing agents, that's an agent, therefore loses. It's a really, really handy picture. M to A. It's something that I teach my year 12s, and it's so important. It stops you swimming around in redox. When you start your A-levels, give me an email and I'll explain that a little bit further for you at A-level. So, okay, since we now know that the negative electrons, so if I have a half equation, if I have an equation and it says this, A plus A neutral, where's the electron going to go? The electron is negative. It's going to be attracted to this guy. It's going over there. Agreed? Let's try another one. Let's do, I've got B going to B minus. Oh, now that's interesting. Where would the electron go? Well, hang on a minute. It has no attraction to either of them, but it has repulsion. Opposites attract, but like charges repel. It's going to go on the opposite side. It's going to go over here. Yeah, because like charges attract, these attract each other, so they're going to go together. And these are going to repel each other. So it's going to go on the opposite side. Yeah, let's give you an even really trickier one. What happens if I gave you C plus going to C2 plus? Which side does the electron go on, Ips? Is it to C plus or C2 plus? Let's see if you can get it. This makes so much more sense. Oh, good, I'm glad. Which side is that electron going to go on, Ips? Two plus. Of course it is. Thank you. Yep. Well done. So the next thing, good job. Spot on, because it's going to have a greater attraction to the 2 plus side. Isn't it amazing when you get little bits of detail like that and it makes so much more sense? Okay, let's try this one out. What about this? If I had D2 plus going to D, which side is it to make it C plus on both sides? Yes, it is. We are balancing for charge and balancing for atoms. Well done. We're doing great. So the next question is, how many electrons and which side? Yeah, greater attraction. So in this case, which side is it going to go on and how many of them will I need? Do you know what? I'll get your email address off you. Oh, I've already got it, and I'll invite you to a Google Hangout, because I think that might actually be easier here. I think it would be. It's just this way it's recorded, and someone else can watch it if they want to. It's going to be, I know there's a big delay. So I'm going to have an electron on that side because it's going to be attracted to it. Absolutely. And how many? And the answer is 2. So well done. Great job. Outstanding. You star. Look at that. You're like a pro already. This is easy. So, okay, let's now go up to GCSE level, because now what we need to do is we now need to start looking at this from a perspective of actual context. So, right, at this point, we're pretty much at the stage where we can start looking at these exercises. Okay, so first of all, I need to scrub something because it's really horrible whenever I get a worksheet where it's wrong. And that is wrong, that, Ips, don't worry. That there. I will mention those answers to you, but I hate that is actually incorrect. Really hate it when they get stuff wrong. But I do have to mention it to you, but those equations were incorrect. So let's now go back to mine. I will explain them, don't worry. Yeah, but okay, let's have a look at this one now. So we've now, like, the first thing we're talking about is we need to decide about this concept of molten or aqueous. So if you look at question number 1, and it's nice to analyze their answers. So magnesium bromide molten, that means the only ions present, the only ions that are present are Mg2+ and Br1-. That's the only thing present in that, so because it's molten. No, if it's molten, there's no water. If there's no water, there's no H+, no H-. So at the negative electrode, who's going to go to the negative electrode? And of course, Mg2+ does. Opposites attract. And then it's going to become magnesium metal. And we can now see it's going to gain 2 electrons, and they're on the left. And we say that that is going to be reduction. Because Rig says you gain, and gain has the word in it. And it's going in. It's on the left. I know it seems awfully complicated, but you get used to this after a while. I swear to God you do. So on the positive electrode, what's going in? So here's my positive electrode. And what's going to hit my positive electrode? What was in the beaker? We had Br-. Right. What's the Br- now going to do? Well done, but you're not quite right. By the way, well done for trying to type that. That must have taken you 20 minutes to figure out how to do that. I wouldn't be able to do it at all. Hilarious. You're right, well done. You said it's going to become neutral. Well done, spot on. But remember, any element that ends in -ene or -gen is diatomic. So it's going to become Br2. Now that means what I now have to do is a process to balance this half equation. First step, to balance half equations. So this is, if you want to make a little set of notes, you can do. Balancing half equations. Step 1, balance for atoms. Balance for atoms. Step 2, balance for charge. Now, the balancing for charge is actually the adding of the electrons. Yeah. So the first thing I need to do is balance for the atoms. I've got 1 Br's gone in, 2 Br's have come out. Right. Next. Right. Oh, don't know. I took off the white. There we go. Okay. By the way, you put your electrons on the wrong side, Ips. Yeah, remember, electrons are negative. Where is it going to go? It's going to be repelled by him. So therefore, it's going to come out, and I'm going to have 2 of them. Now, the reason why I'm going to have 2 of them, this is where it's gone and uncovered my thing there. Yeah, I don't like that. Just don't look at that for the minute. I know that seems crazy. But that's where they're going to go. Does that make sense to you, Ips? Yeah, the electrons are being given to the electrode. Nice, Mr. Duncan. Let's make that a bit thinner. Yeah, the electrons from there are hopping off it and going into the electrode. Yeah, so they're being removed from it. Because remember, oxidation is loss. Ox is loss. Yeah, and what's in loss? Out. Yeah, I know it's hard. I do. Let's look at the next one. Right, the next one. Okay. So this one is, we've got the same substance, but this time it's in aqueous. We've got Mg2+, Br1-, but now it's in aqueous, which now means I now have H+ and OH- as well. Now, here's the thing. People often say, how do I know which one goes to which electrode? Yeah, which of these 2 goes to the negative? Which of these 2 goes to the positive? So I can always tell you, there's a nice one for the positive electrode. This one always. The bromine will never happen. Yeah, it just won't do it. Oh, hang on a sec. Will it? No, I tell a lie. This is group 7. Sorry, tell a lie. That one won't happen in this case. That only happens when there's complex ions going. So I'm going to have this guy go there. It's to do with reactivity in reality. And unfortunately, you do just have to kind of learn that group 7 all go to it and the OH minuses don't. Otherwise, the OH minuses tend to dominate. But group 7 rule on that side. So in this case, we also realize in terms of reactivity. So why is it that hydrogen goes to the electrode? Because hydrogen is lower in reactivity. If you go to the reactivity series, this whole thing of who's gaining and who's losing electrons is to do with reactivity. If I go to the reactivity series and click on images, what you'll see is that hydrogen is really low. Yeah, the hydrogen down here means that the only people who would gain that electron more than hydrogen would be copper, silver, and gold. Otherwise, hydrogen's going to gain it because it's lower in reactivity than these guys. These guys are trying to lose electrons. And there's a bit complication in there, which is metals are desperately trying to lose. That's how you measure their reactivity. The more reactive ones want to lose the electrons. Whereas in the non-metal side, you measure their reactivity on their ability to gain electrons, which is a bit of a nightmare. Right. Let's now try and build some of these. Do you know what we're going to do? We're going to focus on one side. Let's focus on the negative. That right there. Right. I want you to do me a favor. I'd like you please to have a go at the top one. Pause the video. The problem is as soon as you pause the video, we're going to be out of sync. And I am very aware of that. Just type questions as you come to. I'll just kind of speak to you, and you can just type in any questions as you're going along, or tell me to go back if you need to. But have a go at this first equation, and then you can have a look at my answer. If you want, you can just watch me on this one. But either way, number 1, I've got K plus and Cl minus, and it's molten, no other ions. Formula is KCl. Why? Because it's +1 and -1, therefore just 1 and 1 cancels out. Right. The product at the negative electrode. The negative electrode is going to attract the positive one. So I'm going to get potassium is going to be my product. Potassium. Okay, so now we go half equation, right? K plus went in, and I now need to make potassium, which is just K. So which side of the electrons and how many? The positive is going to attract a negative electron, and I'm going to need just one of them. And I'm done. Right. Oxidation is the loss. Loss is out. That's going in. It's gain. Reduction is the gain. That's reduction. Right. Good job. Right. Let's now do the next equation. Right. The next one, I have got K plus and Cl minus. But now I'm aqueous, which means I now have H plus and OH minus as well. Right. So first thing, am I going to get potassium or hydrogen? We're going to get the least reactive. I'm going to get hydrogen, not going to get potassium. But now I always get the chlorides because group 7 dominate. I'm not going to get OH minus. So what's my product going to be? The formula, of course, was just KCl, but now with a state symbol of aqueous. My product of my negative electrode is going to be hydrogen. My half equation, Yep, spot on, well done, great job. Yep, absolutely right, love it. So this one's more tricky because I've got H plus going in, but I now need to form hydrogen, which means I'm going to get H2. It's in a pair. Right, I've got to balance for atoms first, and then say, right, where are the electrons going to go? It's going to go onto the side that's positive, because it's going to attract them. And I'm going to need 2 of them. And I'm done. Is it oxidation or reduction? Oxidation is loss. Those are going in, so it's gain, it's reduction. It's red. You okay with this? Right. So now since we've done those guys, let's now have a look at the positive electrode. Now the great thing is, these are both going to be chloride ion based. So we can go over to the other electrode and say product is chlorine. I'm going to get chlorine for both. Right, the half equation. Well, chloride went in and chlorine comes out. Right. So I need to first of all balance for atoms. There we go. And now I need to balance for charge with the electrons. Now electrons are negative. They're going to get repelled by him. So they're going to end up on the other side. And I'm going to need 2 of them. Does that make sense? By the way, I will send you these worksheets, by the way. I'll email you them so you can have another go at them yourself in your own time. And the second thing is the same one. 2 chlorides go in, 1 chlorine molecule comes out, and 2 electrons. And these are both ox. Right, let's keep going. Let's go to the harder ones. Right, I like these 2. Okay, so I'm trying to zoom. There we go. So sodium nitrate, right? And it's aqueous, so I like this. So I've got Na plus and NO3 minus. Right, I also have H plus and OH minus. Yep, great, thank you. Amazing. So now I've got these guys. Number 1 is I look at my metal. Who am I going to make? Well, hydrogen is way less reactive than, so I'm not going to get sodium. I'm going to get hydrogen. So the formula, of course, is NaNO3. The reason being is it's Na plus and NO3 minus. You have to learn those IPs. Please, please, please learn your complex ions. You need them. Yeah, at the negative electrode, I'm going to get hydrogen because it's less reactive than sodium. I'm going to have H plus is going to go in. It's going to then form H2. Balance for atoms, balance for charge. 2 electrons on the side. That's more positive because they're going to be attracted there. Next, what about the nitrate ion? Right. Well, the nitrate of this is now interesting because we now need to consider these 2 on difficulty of removing the electrons. And it's harder to remove them from a nitrate ion. So now you get the OH minus, that's always doing it. You never get the complex ions actually doing anything. So in this case, it's now going to be the product. Now this, of course, is interesting because now OH minus is going in. I'm actually going to get oxygen. Now that's something which I have to mention to you because OH minus goes in and we're going to rip it apart and we're going to take the electron off it and we're going to form oxygen gas. I know, it's a nightmare. And technically, you need to be able to balance for this. It's an absolute nightmare, this one. And by the way, IPS, they have asked it, annoyingly. So, okay, the problem is, you see, I don't learn anything in chemistry. I just build everything, which is a bit of a nightmare. I'll show you. I don't want you to get overly lost in this. This is part of A-level, but the problem is they're never going to expect you to build this. They're just going to ask you to balance it, IPS. That's all. So we've got OH minus going in, and we're going to get oxygen gas out. Right. We need to run a process from A-level called Moe. So we've got another problem. This is actually straight from A2, just so you know. This isn't even AS. This is AS. This is AS. And then there's extension, which is going to convert, alkali converter for A2. Got to go the full hog here. Don't worry about not being able to do this. This is just me showing off, really. So metal is anyone other than oxygen or hydrogen. Well, I've got no metal, so that's good. Water for oxygens. I've got 2 oxygens there, 1 on that side. I'm going to add water to that side. Next, now that I've done that, I now need acid to balance for H's. I've got 3 H's over there, so I need 3 H pluses over here to balance it. That's H plus is what makes an acid an acid. That's from GCSE chemistry. Once we've now done water and acid, we now need to do electrons. So the electrons, I have got overall charge on this side is 0. That's got a -1 charge, so overall -1. And on this side, I have got 0 and +3. So total is +3. I need to make them the same. Yeah, make them the same by adding electrons to the more positive side. I'm going to add them to this side. I'm going to add 4. You're going to wonder why, because that now means that they're on the same 1 minus charge on each side. The problem is I'm not finished yet. I now need to, this is unfortunately done in alkali conditions with OH minus. So I now need to convert it to alkali. So I now need to do another step here, which is H plus OH minus goes to H2O. And then I need to get rid of 3 of those. So I'm going to go 3 there, 3 there, and 3 there. Then that cancels with that. That one cancels with that to give you 2 of those. Those combine. So there's your overall equation. 4 OH minuses goes to oxygen plus 2 H2Os plus 4 electrons. And I know that's a nightmare. And IPS, they have given you that before on a GCSE paper, and they just simply asked you to balance it. So don't worry, it's not as bad as, and when I say balance it, they gave you this. Yeah, this is in reality how this comes at you at GCSE. They gave you this. Yeah, and just said balance it. That was all. Yeah, so all you said was, well, okay, I needed 2 hydrogens there. I'm going to need 2 hydrogens there. But then the problem is, now that I've got the 2 hydrogens, my oxygens don't add up. But I can put a half in there to make that 1. But then I can't do that. I need to, and then I need to balance it for charge, which is, I've got 2 minuses there. I need 2 minuses, but I can't leave it with a half. I've got to double everything. So I double it. Yeah, 2, 1, and 4, and that should then add up. Yeah, it's just a game, so don't worry about it, and I don't want you to get lost in this. Yeah, let's go for another one. Right. Let's go for the silver nitrate one. I quite like that one. There we go. So we've got Ag plus silver nitrate, NO3 minus in aqueous, H plus and OH minus there as well. Oh, okay, right. So is it better to do Moe or just learn the balanced equation in terms of GCSE? Oh my goodness, you can't get Moe from that 20-second introduction to it. That's hard, man. That's really tough. Just don't learn the, just no, don't even bother learning it. It'll come up and they'll give you it and you just balance it the way that you normally do. Don't worry about it. God, just stick with, you don't even need to learn it because if it comes up at your GCSE exam, they'll give it to you and then you just balance it anyway. Yeah, it's not complicated. You don't have to learn anything. Don't worry about it. I just had to do it because I haven't learned it. 15 years of chemistry teaching and I haven't bothered to learn it yet. Right. So who's going to go to my, is this my negative electrode? Yeah. Who's going to go to my negative electrode out of these guys? Oh, it's a rarity. The answer is silver, because silver is lower than hydrogen. Yeah, it's less reactive, which means it's going to get made. So in this case, I've got AgNO3, and I'm going to get silver at the negative electrode. And what's going to happen? The silver 1 plus is going to form silver metal, and I'm going to add, it's going to get, got it, just normal balancing. Amazing. And then I'm going to add an electron. Which side? On the positive one. How many? Just 1, and I'm done. This gets up easier and easier the more you do this, I promise. Yeah. Okay. I hope that's, do you know what? I'm going to end electrolysis there. I'm hopefully going to say that you've got a better understanding of what's going on now. I will send you that worksheet on an email, including the answers as well. My laptop's gone to sleep. There we go. I'm back. So let's now switch over. I'm not going to do energetics this time round. I don't think IPS. I've been on for 43 minutes. I'm going to do another 15, and I'm going to do your repeating polymers. And then I think the next time we'll try a Google Hangout and give that a try. And that way I can do a one-to-one with you. And you might get a better response there. So let's do our repeating units. So in terms of organic chemistry, so polymers, I'm going to make that a little bit thicker. Polymers comes under the, oh, maybe too thick. There we go. Polymers, there are 2 types of polymers. 2 types. We've got addition polymers, and we have got condensation. You've got to know both for GCSE, but this one is the one that you've asked specifically because they do ask these more. Yeah, and we know that addition polymers are otherwise known as polyalkenes. And I love that name. It literally tells you how to name it, which is amazing, and I love it. So we know that we can have any molecule with a double bond. I don't care what is attached to any of these. I don't care. Anything could be attached. Absolutely anything. Yeah? The reason being is when these polymerize, the double bond is going to break. Let's zoom in. The double bond breaks and it folds out. Folds out to the other side. Yeah. It folds out to be on the other side of either carbon. And then all you have to do is put it in a bracket and put the letter N. So it's really, actually, addition polymers are the easiest ones. Yeah, they sometimes ask you to draw multiple repeating units. That's not too bad. I'll cover that in a second. So let's have a look at a question. Right. They have given you chloroethene. So number one, how do you name the polymer? You literally write poly. The word poly means many. Yeah, and you put in a bracket the alkene. It literally tells you how to name it. Polychloroethene. We're done. That's it. How do you turn this into the picture with the repeating unit? I'm going to break the double. It's not like, oh, hang on. Break the double. Extend it out from left to right. Put it in a bracket and add N. And we're done. How easy is that? It's super easy. Right, and then people see this one and they freak out. They're like, oh, hang on a minute. Sup? Hey, Ange, nice to see you, dude. Man, you're so bored, aren't you? Actually, by the way, Ange, this is Ips. Ips sent me an email. She's actually in the UK and she asked me for some help, so I thought I'd give her a webinar. It's good to see you, Ange. So this one, of course, is clever. It's everything we know here is it's a trap. Yeah, because we go, right, hang on a minute. There's the double bond. I don't care what's attached to these guys. All that's happening is they're trying to trick you. So how do I turn this now into the picture of the polymer? I still break the double bond. What you realize is oh, okay, yeah, I'm pretty bored. What you realize, Ips, is that you only ever have two people in the bracket, two carbons, because these were the carbons. That carbon is that carbon. That carbon is that carbon. And that's it. Everyone else is attached to them. So if we look at the yellow one, the yellow one has two hydrogens attached. So let's put the two hydrogens above and below. The next thing is what's on the blue one? I've got a hydrogen at the top, and then I've got this horrible CH3 group, which I'm just going to put down here. And I'm done. That's it. Not complicated. And put it in. That's it. Don't overthink this. It's really not as hard as you think. I'm going to show you another one. Structure, repeating unit. I don't really like that, to be fair. Yeah. I don't actually like what they're doing there. They're not doing this worksheet's not particularly great in terms of like GCSE. The GCSE, they want that bit. They're saying the repeating unit is if they ask you to draw 3 of them. That's what they're doing. I'm just going to show you one more of these. This is butene. This is butene. So turn that into the polymer. Pause the video, have a go at doing it. What's going to happen? First thing, the two carbons in the double bond. Let's break the double, stick it out to the side. Next, put the people on the yellow one first. Right, so I need a H and I need a CH3. Blue, H, CH3. And I'm done. Put it in a bracket, add an N. I'm finished. If they asked me to draw 3 of them, they said, draw the polymer with 3 repeating units. I'd just go 3 repeating units. That gives me 6. There we go. And it's going to repeat 3 times. HH, CH3. I'm doing CH3 just to make it easy for myself. Yeah, I wouldn't recommend you doing it. Just draw it out. It's just better to do it that way. Just so it, I know you probably say it saves you time doing it that way. And I do understand, it's just not really worth it. There we go. 3 repeating units. Not complicated. I can do a single, I can do as many as you like. Addition polymers are dead easy. They're a breeze. They're the easy ones. So the question is, can we now flip them out? What about that one? Oh, I'm going to give you one that you need to add. Oh, it's already there. There we go. Polytetrafluoroethene, otherwise known as PTFE. You have to know that, guy, Ips. That polytetrafluoroethene is what's on non-stick frying pans. It's the slipperiest substance we've ever invented. Invented by NASA, amazing. So the thing I'm going to say is, what was the monomer? Well, the great thing is that's really easy. If you ever get a picture of a, I've zoomed in a bit far now. So if I've got polytetrafluoroethene, just so you know, little details that teachers sometimes forget, the lines need to go through the square bracket. But if you want to turn this back into the alkene, just put the double bond back. I'm done. How easy is that? Polyalkenes are a doddle. They're the easy ones. Condensation polymers are a bit more tricky. Right. I'll leave you be with that at this stage. We've covered 2 of your things. I'll do one on energetics for you next time. I'll maybe do one. Well, I'll do a webinar during the week for my year 11s on energetics. Happy, God, very happy. Also, if you have a look on my webinars already, I think there was one that was already there. You might want to have a look at that one. It's been an absolute pleasure to give you a lesson today. I hope you're doing all right and staying safe. Thank you so much, sir. This was really useful, and everything we have covered is making so much more sense now. Thank you so much. You're more than welcome, Ips. It's been an absolute pleasure. Take care of yourself. Be safe. Yeah, look after yourself. What I'll do is what I'll also do, Ips, I will send you back. There we go. There we go. I'll also send you an invitation on Google Hangout, because next time we'll try doing it that way. It might be easier because then we'll be able to get a bit more feedback. It still will have the delay, but at least it won't be quite as much of a delay as we do see on YouTube. But I hope it's been handy. It's been great to see you. Have a nice rest of your weekend. Take care.